Alright, grade 8s, we're starting off the year with a chapter, and this is chapter 1, and we're dealing with 1.1 advantages and disadvantages of different graphs. So we're going to start with working example number 1, where we're comparing two graphs. But before we get started, we have a definition for the word interval to look at. And an interval is the spread between the smallest and largest numbers in a range of numbers. So if you've got a set of numbers like 2, 3, 7, 12, 15, 18, the largest number is 18, the smallest number is 2. So the spread is between 2 and 18, which if you subtract 2 from 18 is 16. So you've got a spread that is the size of 16 with that set of numbers. Anyway, let's have a look at this example here in the notes. The owners of Pascal's Pizzeria keep track of the ways people order pizza. They make a circle graph and a pictograph to show the data. This is a circle graph, obviously named that because we have a circle to start with, and it's divided into pieces, kind of like pizza or a pie. It's cut into different pieces, and each piece is labeled with a percentage usually. So this piece is a piece representing the walk-in traffic, which was 32% of the total traffic. Internet orders came from 20% of the sales, and then phone orders was 48%. There's a title here as well, weekend pizza sales, and it also indicates how many orders there were in total for the weekend. So using that number along with the percentages, you can actually calculate how many specific orders there were in each category. But the circle graph shows you the representation of percentages. This is called a pictograph, and it uses pictures, which is where picto comes from. And in this case, they're really blurry pizza pictures. And it shows us here that one picture of a pizza represents 10 pizzas. Again, we have the same title, weekend pizza sales, and we have the same three categories, phone, internet, and walk-in. So across here, we've got phone, which has 1, 2, 3, 4, 5, 6 pizzas. And if each pizza represents 10 people, then that's 10 times 6, so there were 60 orders from the phone. Internet, we've got 1, 2, and that looks like it's about half of a pizza that's drawn there. So it's 2.5 times 10 for each one, so about 25 orders through the internet. Walk-in is 1, 2, 3, 4 pizzas, so 4 times 10 is 40. Now part of the problem with pictograms, or pictographs I should say, when you've got partial images, sometimes it's hard to tell if it's a half a picture, 3/4 of a picture, 60% of a picture. It opens up a little bit of room for error. But in this case, we're going to assume that that is half a pizza. So let's look at the questions now. We'll leave the graphs on the screen. How many more pizzas were ordered by phone than by internet? So we're going to look at the pictograph first. As I said, the pizza symbol represents 10 pizzas, and that's shown here. How many pizzas were ordered by phone? Well, as I said, there were 6 there. So we're going to multiply 10 pizzas per picture times 6 pictures to tell us that there were 60 pizzas ordered by phone. How many pizzas were ordered by the internet? 1, 2.5 pictures times 10 pizzas for each picture, so 10 times 2.5, and that works about to be 25. So we are assuming that that is a half pizza there when we do this. How many more pizzas were ordered by phone than by internet? Well, we have to do some subtracting. Telephone orders, we said were 60. And internet orders was 25. So we're going to take 60, subtract 25 to find out the difference. And in this case, that means the difference is 35. So 35 more pizzas were ordered by phone than by internet. So that's that. Let's turn the page. Question B. Almost half of the orders were by phone. Which graph clearly shows this, or shows this more clearly and explain? Okay, so here are the two graphs again. If you look at the pictograph first, phone orders were half. It's not real obvious just from a quick glance at this graph that that is the case. You can count, and we counted that there were 6 here, so 7, 8, 9, 10, 11, 12 and a half pizzas total shown here. So yeah, 6 is pretty close to half of that. So you can calculate it out if you do the work to see that. But if you look at the circle graph, it's quite obvious. The phone section of the graph is pretty close to half of the circle. So really the circle graph is the better way to see that particular question. So the circle graph shows that 48% of the pizzas were ordered by phone. The circle graph shows this more clearly because about half of the graph shows phone orders. Question C, which graph should you use to show the number of pizzas ordered by internet? Explain your choice. Okay, so we've got a couple of ways to look at this. We're going to compare each one. The pictograph here is the best way to show the number of pizzas ordered by internet. It uses one pizza to show 10 pizzas. To show the orders by internet, it uses 2.5 pizza symbols. So as we've already calculated, 2.5 times 10 is 25. So 25 pizzas are ordered by internet. The circle graph, though, shows that 20% of the 125 pizzas were ordered by internet. To figure out the number of pizzas itself, you need to do a calculation. And you need to calculate 20% of 125. To do that, convert your 20% to a decimal. So we take the decimal in 20% and we move it over 2 spots to the left. So 20 becomes 0.2. That's your decimal, which is here. Of means multiply in this case, and then 125. So we're calculating 0.2 times 125. And if you punch that in on your calculator, you're going to end up with 25 pizzas. So both graphs show you 25 pizzas were ordered by internet with a little bit of calculation. This calculation here is the pictograph. This calculation here is the circle graph. The math is much easier on the pictograph in this instance than it is on the circle graph. So the pictograph makes it a little bit easier to answer the question. Now, we can ponder other things. Part D asks, would a line graph work to show the data? Why or why not? A line graph would not work because there's more than one category of pizza orders. We've got phone, we've got walk-in, and we've got internet. A line graph, you can't really display that. A line graph is better for showing trends over time, for instance, not across different categories. So you need a graph that compares data in different categories. So what other kind of graph could you use to show the data? Well, another graph that we commonly use are bar graphs. And in fact, if you look at the pictograph and turn it on its side, you could very easily turn these rows into bars. And then all of a sudden you've got a bar graph. So a bar graph lends itself very well to this type of question. Okay, working example number 2 now. We're going to look at some hockey, representing data. During the 2005-2006 NHL season, the Edmonton Oilers played in the Stanley Cup Finals. Long time ago, you guys were less than a year old, probably. It was a good year for hockey. Sean Horkoff and Jarrett Stoll were 2 of our team's top players. And here are their statistics for the 3 seasons leading up to that 2005-2006 season. So we've got a chart here showing Sean Horkoff's points over the 3 seasons. It's season 1, 2, and 3. It shows the number of games played in each season, the number of goals scored in each season, the number of assists that he earned in that season, and then the total number of points in that season. This chart shows you the exact same data, but it's for Jarrett Stoll instead. So part A is asking us to make a double bar graph to show the data. Well, season 1 and season 2 are done here. We've got a graph. Title is total points in 3 NHL regular seasons. Along our y-axis, we have points ranging from 0 to 80, and each line it jumps 10 points. Across our x-axis, we've got the season number, 1, 2, or 3. And here we've got a legend. That legend shows us that the white bars are the points for Sean Horcoff, and the shaded bars are for Jarrett Stoll. So let's have a look. Season 1, total points, right? So 33 for Sean Horcoff. And if we look, yep, that's 33 there. For season 2, he hit 40. Yes, that's what's shown here. For season 3, we don't have it on there, but we know it's 73 points. So let's add that onto the graph. So season 3, 73 is going to be about right here. And so we can add that in. Now let's have a look at Jarrett Stoll. 1 point in season 1. Okay, yep, there's a little sliver here that shows 1 point. Season 2, he had 21 points. Yep, that lines up. And then season 3, much better. He hit 68 points, so almost as high as Horcoff. So 68 is going to be about there. So we can add that in. And Jarrett Stoll is the one that's shaded, so we're going to shade this in. So there, now our graph is complete for the 3 seasons. And you can see that both players improved across those 3 seasons leading up to the playoff run. Now, question is, which player improved the most in total points? So improving the most means you need to compare a starting point and an ending point. So Stoll had 1 point in season 1 and 68 points in season 3. So we're going to compare those 2 seasons. We're going to actually subtract to find the difference between the 2. So take the larger number, 68, subtract the 1. So he improved by 67 points from season 1 to season 3. It's a pretty big improvement. Horcoff, we'll compare now as well. In season 1 had 33 points. And in season 3 he had 73 points. So same strategy, we're going to subtract the difference to calculate the difference. So 73 minus 33 means there was a difference of 40 points. So Stoll improved 67 points, Horcoff improved 40 points. The one that improved the most would be the larger number, the 67, so that means Stoll improved the most in total points across those 3 seasons. Turn the page. Question C. Coaches sometimes use the total points to judge how good a player is. Look at the number of games Horcoff and Stoll played. Are total points a fair way to judge a player? Maybe, maybe not. Let's have a look. How many games did Horcoff play in the 3 seasons? Well, let's add them up. These are Horcoff's games played right here. So 78 plus 80 plus 79. When we add that up, it turns out to be 237 games. That's how many Horcoff played in those 3 seasons. How many points did he score? Well, let's add that up. So 33 points in season 1, 40 in season 2, and 73 in season 3, for a total of 146 points in 237 games. Not bad. Let's now have a look at those same stats for Stoll. Games played, 4. He must have been injured that year. 68 in season 2, and 82 games in season 3. When you add that up, it's only 154 games. Now the point total, let's add those up. So 1 point in season 1, 21 in season 2, and then 68 in season 3. When you add that up, it's 90 points. So, are total points a fair way to judge a player? No. If, for instance, if you look at just season 1, Stoll had 1 point, but he only played 4 games. If you're only looking at points, that looks miserable compared to the 33 points that Horkoff scored. But he played 78 games. You need to look at more than one variable when you're assessing the statistics on a situation. So total points are not a fair way to judge a player. Horkoff earned more total points than Stoll because he played a lot more games than Stoll. Alright, last page here. Part D. Are the two circle graphs a good way to show these data? Why or why not? So the title here is Horkoff's total points in 3 NHL regular seasons. 146 points. Here we show that season 3 was 49% of those points, season 1 was 22%, and season 2 was 29%. Stoll's, most of his points came in season 3 at 76%, 1% only for season 1, and season 2 was 23%. So, looking at this, no, circle graphs are not a good way to show the data. Each circle graph shows the percent of points scored in each season, not the total number of points for each season. It's difficult to see how many points each player scored in season 2. You can do the calculations because you've got total points and percentages, but it's not easy to see it. And so that's chapter 1.1.